We are just after T-minus 3 minutes away from liftoff, so let's check in one last time with the status of this rocket. Fuel is fully loaded on both stages, and liquid oxygen is being topped off as we speak. Right now, the rocket is pressurizing itself with helium gas, sort of like a soda can derives some of its strength from the pressure inside. The Falcon 9 is pressurized with gaseous helium, and we press that up just before releasing it from the strongback. You just saw those cradle arms from the strongback release, and right now the transport erector strongback is reclined to its launch position at 77.5 degrees. Right now, the range is still giving us a green light for launch. The weather is again looking fantastic. Those upper level winds are still playing nice at 95% launch tolerances. Remember, this is an instantaneous launch window, so if for any reason we decide not to go today, our backup window will be tomorrow at 6:17 a.m. Pacific time. Right now, the rocket's getting ready to launch, so let's listen into those countdown nets as we approach just under T-minus 2 minutes.
Falcon 9 is on internal power. Vehicles in self-line. Gas loads are closed down.
AFTS is ready.
Falcon 9 is in startup.
LD, go for launch.
T-minus 30. $20. 15.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Vehicle is pitching downrange. Stage 1 propulsion is nominal. Power and telemetry nominal.
For those of you just joining us, you are watching the Falcon 9 as it descends through the atmosphere, carrying the PAZ satellite to a polar sun-synchronous orbit. Right now, the rocket is approaching what we call max Q. This is the point at which the aerodynamic forces in the rocket are at the greatest. Falcon 9 actually throttles itself down as it passes through max Q and then throttles back up once we're through it.
Vehicle has reached maximum aerodynamic pressure.
We just passed through our maximum aerodynamic pressure, max Q. That Falcon 9 rocket is now throttling back up to full speed as it ascends through the atmosphere. As that first stage ascends higher and higher through the atmosphere, the ambient air pressure starts going further and further down, so you can see those exhaust gases getting bigger and bigger on your camera screen right now. In about 20 seconds, we're going to be passing through what we call MECO, which is main engine cutoff. That's when that first stage is going to complete its burn. Shortly after that, we'll have stage separation, and then second engine start, SES-1. Let's watch that happen now.
We have MECO.
You just saw it on your screen. That was a good MECO, main engine cutoff, a good separation of that first stage, and then what appears to be a successful second engine start 1. Stand by for fairing deploy. And you just saw it on your screen. That was a successful fairing deploy. You can see the fairing falling down below the second stage on your screen right now. SpaceX will be attempting to recover this fairing today. On your screen right now, you can see the Merlin Vacuum D engine nozzle. This is a radiatively cooled engine nozzle, meaning that it vents the heat from those hot exhaust gases by radiating that energy. You can see it glowing red hot, burning that energy away. For those of you down in Southern California, you might get a good glimpse of those exhaust gases as the second stage accelerates. Looked like a nice clear morning today in Los Angeles. As the second stage ascends higher and higher into orbit, let's talk a little bit about exactly what orbit we're going to today. This is a low Earth orbit polar sun-synchronous orbit. Low Earth orbit refers to the height of the orbit above the Earth, so things such as the International Space Station are also in low Earth orbit, but they orbit more along the equator, which is what's called a low inclination orbit. A polar orbit circles vertically about the Earth with respect to its poles, so that it passes over the north and the south poles. This is the orbit we're going to today. Certain types of polar orbits, like this one, a sun-synchronous orbit, keeps the orbit's plane directly in line with the sun. This allows any satellite that's in a sun-synchronous orbit to see all points of the Earth from exactly the same lighting conditions as illuminated by the sun. This is extremely useful for imaging applications, which would be the PAZ spacecraft's primary intended purpose. Low Earth orbits only require a single burn, so we won't be having a coast phase or a second engine start 2, like we would normally have for geosynchronous Earth orbit launches. For those of you just joining us, we did have a successful liftoff of the Falcon 9 rocket at exactly 6:17 a.m. Pacific time from Space Launch Complex 4 in Vandenberg Air Force Base. Shortly after that, the first stage completed its job and separated from that second stage. We're currently watching the second stage as it continues its first burn, its only burn today, and accelerating that PAZ spacecraft to a low Earth orbit. The next major event is going to be at about T plus 8 minutes and 58 seconds. That's when that second engine cutoff is going to happen, also known as SECO. Right now you can see the curvature of the Earth just behind that Merlin Vacuum D engine nozzle. All telemetry is still looking nominal from that second stage, getting good signal. As we burn fuel in that second stage, the second stage actually gets lighter and lighter, but the engine thrust remains the same. So in order to keep a constant acceleration on the second stage and its payload, we actually throttle that Merlin vacuum engine down towards the end. We're getting close towards the end of the burn right now, so that throttle down is beginning. Coming up next in about 40 seconds is going to be SECO, second engine cutoff. That second stage Merlin vacuum engine is going to shut off, having completed its primary burn. And then a minute after that, or 2 minutes after that, we're going to have payload separation. So stand by for SECO in about 20 or 30 seconds from now.
Stage 2 is in terminal guidance.
And yes, is safe.
You have SECO 1.
And you just saw it on your screen, that was a second engine cutoff right there. The second stage has now completed its burn, and that's Merlin vacuum engine is off.
Confirmed good orbit insertion.
We just got confirmation of a good orbit. That means that we have reached the intended low Earth orbit point. Right now, the primary payload, that PAZ spacecraft, is still attached to the top of the second stage by way of a payload adapter fitting. It has some locks and some springs. In about 1 minute and 30 seconds from now, those locks are going to release, and the springs will give the PAZ satellite a gentle push away from the top of the second stage so that it can begin its own journey into low Earth orbit. We are now 1 minute away from that payload deploy. Like we were saying earlier, we're going to be having or hopefully we'll have a view from the top of the second stage looking at the PAZ satellite as it deploys. You may see on the sides of the spacecraft, you're going to see 2 extra things. Those will be the SpaceX demo satellites. We'd love to give you footage of those deploying too, but unfortunately, the second stage will be passing out of ground station coverage before those satellites deploy. So we're just going to be covering that primary payload PAZ satellite deployment. Stand by for deployment in about 10 to 15 seconds. And there you can see it. That looks like a successful separation of the payload of the PAZ satellite. You can see those SpaceX demo satellites to the left and right of the payload adapter fitting. But the primary payload is right now gliding away from that second stage. Soon it will unfurl its own solar panels and start communicating with the ground teams. So right now, this is going to bring an end to our webcast coverage. For those of you who just joined us, we had a successful launch from Space Launch Complex 4, successful stage separation and a good second engine burn, and then finally, just now, a good separation of that PAZ satellite. I'd like to thank the customer PAZ and ISDASAT for allowing us to launch their payload to low Earth orbit today. I'd like to thank the Air Force and the Range and the FAA for their support of today's launch, and of course, you, the viewers, for waking up bright and early on this Thursday morning to watch the Falcon 9 launch. Unfortunately, we can't bring you coverage of those SpaceX demo satellites. We don't have ground station coverage to show you, but you can follow us on social media for updates on the demo sats and their mission. If you'd like to come work for us, please check out spacex.com/careers. Yet again, thanks for letting us share this Falcon 9 launch with you, and have a great rest of your day.